Hi, this is Hayden. I'd like to give some feedback regarding the Chapter 2 web assignment. And I'm going to start by scrolling down so I can bring this image into view. This is the brain, looking at it from the left side. So we're looking at the left hemisphere. And so here, this is the front. So here we have the frontal lobe up here, the parietal lobe at the top, temporal lobe at the side of the head, and in the back we have the occipital lobe. Now, in each case there is a left and a right. So for example, if we're talking about the frontal lobe, we've got a left frontal and right frontal, left temporal, right temporal, and so on. Okay, with that in mind, let me scroll up and get to these answers here. So the first one was to look at these activities and figure out which lobe was primarily involved. Now, the brain works holistically, so it's the case that the lobes and many structures are working together, but for the purpose of kind of understanding the brain, we'll make it simple and say which lobe was most involved. So looking at a picture, that's a visual input, so that's going to tell us that it's the occipital lobe, because that's processes vision. And then we're looking at it with two eyes, so the left and right visual field is getting to the occipital lobe, so that means both left and right occipital lobes are involved. Feeling a rough texture with your right hand, we know that touch sensations register in the parietal lobe, and since we know that this is the right hand, and we know that the opposite side of the brain controls the opposite side of the body, right hand must make it the left parietal lobe. And listening to music, auditory stimulus, that goes to the temporal lobe, and in this case we're listening to music with both ears, obviously, so that's both left and right temporal lobes. Stepping on a tack with your left foot. Now this one I think I gave credit for frontal and parietal both, because if you think of stepping, like moving your foot, that's going to be a frontal lobe kind of activity, because the motor cortex is in the frontal lobe. If you think in terms of feeling it, that's going to be the parietal lobe. But in both cases, it's going to be the right. So if you put the frontal lobe, it would be the right frontal, parietal lobe, it would be the right parietal, and I believe I gave credit for both of those answers. The next series has to do with this reflex arc, and it's pretty straightforward. Afferent neurons carry sensory information to the spinal cord and brain, and then efferent or motor neurons carry them back to the muscles. The next activity had to do with subcortical or brainstem area. So we know it's below the level of the cortex here. And I was looking for something specific. So many people put hindbrain. That's too general. You have to be more specific. Arousing the cerebral cortex so that you wake up to a strange noise. That's the function of the reticular formation. Reticular activating system alerts the brain. Pay attention, something is happening. After impulses from the right hand have been received, what is it that sends these impulses to the opposite side of the brain? Now, the way the brain works, we have the left and right hemisphere as we observed. Then there's a set of tissue that serves to connect. That is, it sends fibers, or you kind of visualize it, send horizontal inputs to the left and to right, so that if something registers in the right hemisphere, that information gets to the left hemisphere as well. The structure that does that connective kind of in the middle, is the corpus callosum. Sending impulses from the eyes to their input area. Well, information comes in through the eyes, is changed to a neural impulse. The thalamus is the main relay station, so that would send it to the occipital lobe. Likewise, information comes in from the ears, synapses in the thalamus, and the thalamus directs it to the temporal lobe. Now this is very obviously an oversimplification, but kind of makes the point. Controlling respiration, Pons and medulla. Medulla was the main answer I was looking for, but the pons is also involved in that. Coordinating movement. Now, motor behavior is initiated by the frontal lobe in motor cortex, but the part of the brain that coordinates it, that smooths it, that makes it possible for you to reach and grab a glass, for example, that is the cerebellum. And then the rest is that kind of just definition, somatic branch of the peripheral nervous system, and then the autonomic and sympathetic. So those, I think, are pretty straightforward. Okay, most of you did pretty well on this, but I don't think anybody got a perfect score. Maybe one or two people did. So a little review might be in order here. Okay, good luck.